Hey there! Today, we're going to look at how to turn a REST-based API into a data stream in Kafka. Now, why would we do that in the first place? Well, REST APIs are cool for a lot of reasons, including their popularity and maturity. But, basically, sometimes the data we need to process with Kafka is in a REST API, and we, as developers, don't really have a choice. But we can take the data that's in the REST API we're given, clean it up, and make it replayable with Kafka and Flink SQL. My colleague, Dave Troiano, recently created a demo that does just that. Grab a cup of coffee, get comfy, and join me as we take data from the OpenSky Network's REST API and turn it into a data stream. Let's get a couple of prereqs out of the way. You're going to need a Confluent Cloud account, as well as an installation of the Confluent CLI and the Confluent Flink Quick Start plugin. We also ask that you review the OpenSky Network's terms of use. All of these resources are linked below. First, we'll clone the demo repo. Then, I'll log into Confluent via the CLI. Then, I'll run this command to spin up a Kafka cluster and Flink compute pool in the Confluent Cloud. It'll run for a few minutes, then, ta-da, we'll be in an interactive Flink shell. We'll run this Flink SQL statement, but there will be no tables yet because we haven't produced any data into the system. Let's fix that. Now, we'll launch the HTTP source connector. We'll use the script included in this repo, createconnector.sh. While that's running, let's take a look at a couple of the connector configs. We're pulling OpenSky Network's all-state vectors URL. And for this demo, we've actually bound the data to this specific area of Switzerland, using this piece of configuration that determines the latitude and longitude. And this is the polling integral we're using. Okay, let's validate that our connector is up and running. We'll click on HTTP Streaming Environment in our Environments tab, then click our HTTP Streaming Kafka Cluster tile to view the details. Then, we'll click Connectors in the left-hand nav to see that our OpenSky Flights connector is running. Now that we've got some data flowing, will our show tables command work? Let's check it out. Let's take a look at the table structure as well as what the data looks like. Now, this is pretty much in the same shape as the data from the API. It's not ideal. There's no self-documenting schema for the states field, and there's some white space here. Also, for each row in the all flights table, the states column represents all aircraft in the given bounding box. Let's roll up our sleeves and clean this up with some Flink SQL processing. We'll run this statement to define a new table or view. Before we run the insert query to populate this table, let's pause to note a couple things. The states array in each row of the all flights table is getting expanded into new rows, one array per element, by this cross join against the unnesting of the states array. The two timestamp fields, one for the poll time and one for the reported event time, are converted from Unix epoch longs to timestamp LTZ timestamps. String, numeric, and Boolean fields are typecast accordingly, with string fields are trimmed to remove any white space padding on the right. Okay, let's see how our table looks now. Whew, that's much more readable, don't you think? You probably don't want to leave this running forever. In order to delete all the resources in your Confluent account that are related to this environment, you can just delete this environment. Find the environment ID with this command. Then, delete it. There. Leave nothing but footprints, as I always say. If you have any questions, leave a comment below, and Dave and I will do our best to get back to you. Don't forget to like, share, and subscribe to the Confluent channel. Thanks for watching, and see you next time.